Okay, I'm going to have some fun designing a two-band FIR filter, initially linear phase. I'm going to extend that then to a two-group delay situation and hopefully also to an IIR extension. Here's Slifer in its standard default form. I'm going to go up here and change to bandpass filter and produce my two bandpass segments by popular suggestion here. I'm going to 0.09 on one band edge, 0.11 the frequency for that one, 0.19 here, and then 0.21 on this edge here. This gives me one of my segments. This red line is my target profile. I'm going to export that to the target profile calculator. In fact, it's already gone in automatically. You can see it sitting there waiting. Here's DC. I'm going to put this off to the side and now work on my other segment. I'm going to sweep down from this way, making this nice and symmetric. This is going to be 0.41. This one's going to be 0.39. The other one is 0.31, and then 0.29. Oops, don't need that command window. 0.29 here. So this is my other segment. 0.29, 0.31. Yes, so that's all the pieces that I want to have. I want to now go back to my target profile calculator and get this other red piece. I'm going to get the Slifer profile which I've just drawn, put it onto display B. You notice this is display B, and I'm going to make it work in conjunction with the previous one in A. But what I really want is A plus B, so I'll call this up down here and store that in display C. So at last I have this. In fact, I'm going to save this for safety. I'll drag it over there as well. So this is the thing I'm actually going to try to design to. I'm going to export that back, so I'm going to send that profile, which is on C, back to Slifer. And lo and behold, there it is. This is my actual design. I don't like the low number of coefficients here, giving a pretty crummy job. I'm going to go for 101 coefficients. Nice and beefy sort of filter. And there's my finished product. This is my linear phase multi-band filter, in this case two-band filter. I can check it by going up here to the tools and CPIG. I can note its gain. I could, if I wish to, look on dB as well. I can do that in various ways, but I can also check that this group delay is completely flat at 50 samples, which is going to be important for me in my next extension. So that's a finished task, but I would now to explore whether or not I can have more group delay in this passband than there is in this passband. And so I'm going to go back to my target profile calculator and try to make that happen. So where is it? Underneath here. I drag it back up. Right, it's on top now, and I'm going to be first trying to compose something that can act as my group delay. I'm going to try to make it have 60 in one band and 40 samples worth of group delay in the other. So how am I going to do this? I'm going to come down here and build the whole thing on a plateau of 50 samples worth of group delay, and have 10 on top of that for this segment here. And I'm going to take away 10 times that on this segment, store this in V, and have a look. Yeah, so there it is. It's going to be 40 across here, 60 across here. And the only thing I don't like about this scenario right here, this is my intended group delay, or approximate group delay I'm going to try to have, is that these little sharp edges here are going to upset it. So I'm going to try to smooth that. I'm going to remember my MATLAB filter command and do a bit of smoothing. So this is going to be filter. I'm going to do it with a 100 point moving averager. So I'm going to do a 1, 100 divided by 100. That's going to be my B and my A, and I'm going to act on trace this one here, trace big B. and I'm going to carry out that smoothing operation, deposit the thing in C. Okay, so that does have a little bit smoother edges now. I think I'm going to like that better. The only thing I don't like about it is that it's not even symmetric anymore. My group delay needs to be even symmetric for a real filter. So I'm going to clear this away and just impose this. I'm going to call it my even part operator. Operate on trace C and make that happen onto trace B. So here it is. So now I have a target for my group delay. I have, hang on, I don't have the right thing over here yet. I've got to drag this one up. This is multiband, isn't it? So this is my multiband gain I'm trying to have, and I'm trying to attach this group delay to it. So there you have it. I'm trying to have 40 across one band, 60 across the other, samples that is, in terms of group delay. So I clear away my accumulator and bring in this specially stored up command here, which is gain group delay. It acts on trace A as gain, trace B as group delay, and it's aiming for 101 coefficients. I memory store that in C, and this, because it's two colors, is indicating a real and imaginary part of the target, and I ship that off. I send that profile to Slifer, the one that's on trace C, and there it is. The reason it switched to nonlinear phase, sure enough, this is not a linear phase situation. I need to, in order to get a sensible story, I need to go to the linear gain display, and there it is. So this is now my two-band filter. I just wonder how nicely my group delay filter has turned out. You notice that this is not symmetric, so this set of coefficients is not a linear phase set. Let me go to my tools, examine this, and see what I've got. Well, there's my gain pretty much as before. Have a look at the group delay, see what I've achieved. Well, as usual, group delay goes blasting way off the scale. I'm going to come in here from, I don't know, 30 up to about 70 and see what I've got. Well, not so bad. Across this band here, my upper band of about 0.31 to 0.39, I was hoping for 40 samples worth of group delay, and I'm not far off. You notice there it is going along here about that much. Back here, which was my band between 0.11 and 0.19, I had hoped to boost this up to 60 samples worth of group delay, and sure enough, pretty close. So my judgment on my FIR filter with 101 coefficients is reasonably good approximation, certainly for the amount of effort I've put into it, to the two-band, two-group delay scenario. Well, that would be nice if I could now perhaps turn this into a cheaper IIR filter. For that, I need to export this target, which is residing in the red curve here. I'm going to export that to a different tool. This is the one called Sketch-a-Filt. So I go here to export frequency target profile to Sketch-a-Filt. When I do this, Sketch-a-Filt, the other tool, will come up. Let me get target profile calculator all the way out of the way. I don't think I need that. And sure enough, here's the gain. At the moment, it's designing with frequency sampling only 63. Let me go to 101. And okay, so that's the design I previously had, but it's an FIR design. Now, if I attempt to make use of my Brandhausen, that is to say Brandenstein-Unbehausen algorithm here, to match this filter, let's see what sort of luck we'll have. At the moment, I'll be trying to do it with 29th order. This will be, roughly speaking, 29 numerator coefficients, 29 denominator coefficients. So round about half of the size of the FIR filter. Well, it's not doing that good of a job. I need to boost this up. Let me juice this up to maybe 39. That's probably a little bit better than necessary. Let me come down to 34 or something. It's beginning to lose it there. Let me come up to about 37. and I can see that around these edges it's pretty good. I can see them up here by viewing all the filters, both the filters in this case, and there they come up, frequency sampling and the Umbehauen. I can look at it in terms of gain, and I can see that, well, the green one is not coming down quite so far. This is a bit deep anyway. I'll go down here to minus 100 dB, and there you can see the price that of leveling out that far. So maybe I should actually go back up to a bit higher. Let me go up to 41 or something and see what I've got now. Okay, now I can see the stop band has come down here pretty well. Let's just see the Brandhauen all by itself. Toggle to that. That's the Brandhauen in terms of gain. Looks reasonably good. These are the pole zero pattern, but what about the group delay? I wonder how well we've done here. Well, I'm going to have to come in here from about 20, well 30 maybe, to about 70 to be able to see it. Well, you can see that here I've got my 60 more or less across here. I've got my 40 more or less across here. So for a smaller number of coefficients, that is to say roughly 82 coefficients, because I had 41 top and bottom, I've now got this stable IIR filter, 2 bands, 2 group delay situations. Pretty successful.